Okay, this is lesson 6-1, and it's page 3. And if you look at the top box, it's talking about converting from vertex form to standard form. And the second box is converting standard into vertex. So let's kind of look at what they did right here. So it's in vertex form right here. And they write it down twice and they FOIL it because of the squared. And so then they FOIL it. They are taking it from vertex form into standard form. And they say, well, remember that x plus 7 parentheses squared is written twice, and then you FOIL it. So they FOILed it. They did first, outside, inside. Outside gives you 3x, and another 3x is 6x, and then the last terms is 9. And then the big thing here, you got to distribute this negative, or not the negative, distribute this 2. And that's what they did right there. And then combine like terms. Okay, so let's go ahead and jump down into the examples and do this for ourselves. This one will be a pretty, will be easier than example 4. So we're going to convert WX into standard form, and we want to find the y-intercept. So that's the two things that we need to do. So WX, and if you go back and look at that example, they wrote that down twice because it's x plus 2 squared minus 6. Okay, and so we're just going to FOIL and simplify and combine like terms. So when you FOIL, you're going to do your first terms, which is x squared. I'm just going to leave this 8 on the outside. We have to distribute it. And so we're going to do x squared. Then we're going to do the outside, which is 2x. The inside is another 2x. And then the last is 4. And so basically showing the work of the foiling. Then you're going to distribute. Actually, I'm going to go and combine like terms before I distribute the 8. So combining like terms, I have x squared plus 4x plus 4 minus 6. So now I'll distribute the 8. So I'll let you do that. Oops, distribute the 8. Get 8x squared plus 32 plus 32 minus 6. So I distribute the 8, and then 32 minus 6 is 26. So we'll rewrite x squared plus 32x plus 26. So that's all you're going to do on that. And on your assignment, that's converting from standard, this is vertex form into standard form. Now it says identify the y-intercept. So if you go back and look at the very first page, page 1, it said the y-intercept in standard form is 0, whatever you get when you plug in 0. So if I come into this equation and I plug in 0, I'll get here and 0 here. I'm just left with the 26. And that's me plugging in 0 into the function. So 26 is the y-intercept. So this is the equation in standard form, and that's the y-intercept. Okay, let's go back up and look at converting from standard to vertex. Now that's going to be more challenging, and it's going to require completing the square. So they have 5 steps here. And the first step, if you can see, is they moved the 17 over here. So it said move the constant term to the left side. So done. Then it says remove the numeric factor from the quadratic and the linear term if the quadratic has a coefficient other than 1. See, this coefficient is not 1, so they took out a 3. They factored out a 3. You cannot have a leading coefficient when you complete the square. We've talked about that when we were working on completing the square. You have to factor out that 3. Okay, number 3. You're going to add the value on each side that makes it into a perfect square trinomial. Remember to multiply the numeric factor on the constant term side. So we're going to complete the square here. They took their, to complete the square, you take your negative 6x or your negative 6, and you're going to half it. So when you half it, you get negative 3. Negative 3 is what goes right here in your perfect square. So always go ahead and write that down because I already found it. So I take the negative 3 and then I square it, and that gives me 9. So they're leaving blanks here in preparation for completing the square. Then, so when they complete the square, they put a 9 here. And then we have to remember to offset 3 times 9 because really I'm doing 3 times 9. Then they combine like terms here. And there's your nice little perfect square. And then they went ahead and subtracted over the 10. So number 4, factor the perfect square trinomial, simplify the constant terms, and move them on the same side. And hint, it says to do b divided by 2 squared. That's what we did right here in this area on the side. So I usually do that to the side. Okay, the only way you can just kind of get this is just to jump in and do it. So we're going to go down here. This is in vertex form, and then they want us to put it in vertex form. It's actually in standard. They want to us to put it in vertex. So we want to write it in vertex form. We want to identify the vertex, axis of symmetry, and our maximum and our minimum. Now I'm just looking at the equation, just going over what we learned before. When you look at this negative here, that means that it opens down. And if it opens down, then it has, the vertex is a maximum. So I already can tell that that's going to be a maximum. And I'll just need to find the vertex and the axis of symmetry, but we can tell what it looks like. All right, so let's go ahead and just jump in and start solving this. So I'm going to write the problem out first. And I'm going to write hx is equal to negative x squared plus 10x minus 16. Now, if you remember looking at the steps, the first thing they did was bring the constant over. So we are going to add 16 over here. So I'm going to do a rewrite of 8 plus 16 is equal to negative x squared plus 10. We're just doing this in preparation of making a nice little perfect square. The next thing it said in the instructions on number 2, it says you can't have a coefficient, only the coefficient you can have is 1. Well, if you look, my coefficient right here is negative 1, so I need to take out a negative. So I'm going to do that next, taking out a negative. This side is just rewrite. It's organizing. You got to keep your problem organized. When I factor out a negative, what happens to this sign right here on the 10? I hope you're saying that the sign is negative. And we can tell because when I redistribute the negative, when I redistribute a negative and a negative make a positive. So, it's got to work. Okay, I'm going to close this. Okay, now we're getting ready to complete the square. So we want to make a nice little perfect square. So I'm going to rewrite over here. And then I'm going to do plus blank. That's my offset. I'm just rewriting plus blank. That's going to be my nice little perfect square. Now, if you remember, to get your perfect square, you're going to take your middle term, right there, the -10, and you're going to half it. And then you're going to square it. Half it is -5. And I'm going to go ahead and stop and write right here, x squared, let me go back, minus 5 is what's going to go right there. I'll refer back to that in just a second. And we'll talk about that. So you're going to half it, and then you're going to square it. So when I square -5, I get 25. So what goes in this spot is 25. That's my perfect little square. That's a perfect square trinomial. When I offset that, I have to remember that it's -1 times 25. That's the most common mistake right there. So -1 times 25 is -25. Okay, I'm going to go ahead and clean up this side. And 16 minus 25 is a -9. And then I have my perfect square over here. Everything is... Now let's talk about that again. So when I halved it, I put that number right there. And whatever that sign is, if it's negative, then that's going to be negative. It's whatever I get when I half it. And I just go ahead and write it down underneath because I know what that's going to be my perfect square trinomial. If I wrote that down twice and foiled it, I should get that. So you can actually check yourself. All right, let's keep going. We're almost there. Let me, kind of need to zoom out just a bit so I can have room to write. Okay, now, all I need to do now is it says to, in number step 5, to simplify the constant terms and move them on the same side as the quadratic expression. So I'm going to take my 9 and bring it back over here. Okay, I'm done with this problem. I just got to do a final rewrite. So I have hx is equal to -x minus 5 squared plus 9. All right, this is in vertex form. So I can go ahead and box this. This is in vertex form. You can go back and look on the front of the paper, the front of your paper, the first page. And it tells you about vertex form. And I'm just going to write the general equation for vertex form underneath it so that you can see it's h minus k, or x minus h plus k. That's standard form. So if you go and look, your x or your h is 5 because a negative, it's a 5. So my vertex is hk, which is 5, 9. 5, 9. So that's my vertex. And then your axis of symmetry. Can't read my handwriting. I was trying to hurry because axis of symmetry is going to be x equals 5. And then we already said that it was a maximum. Right here we said it was a maximum at our vertex. Okay, so the things that I'm going to be looking for when I check this is I'm going to be looking for this equation, the vertex, axis of symmetry, and that the maximum is 5, 9. All right, that is page 3 of the notes.